You're listening to the Maritime Gardening Podcast, episode 132, brought to you by Vessi Seeds. Well, folks, today, once again, we've got author, teacher, master gardener, blogger, YouTuber, mythbuster, and speaker of truth, Robert Pavlis, here to talk about his new book, Plant Science. We had him here just before the holiday season to talk about the book, and we only got about 2 chapters deep, so I begged him to come back to sort of finish answering all my odd questions about the book. So he's here. Robert, say hello.
Hello, everyone. Glad to be back.
Yes. Yeah. So, boy, it's been a crazy winter this year. As I talk to you right now, it's Thursday, March 2nd. We are in the midst of a wicked snowstorm. We're going to get about a foot of snow tonight.
Yeah, we had it a few days ago, and today was sunny and beautiful, and tomorrow we're getting the next storm.
I don't know what it was like for you, but I feel like winter is just starting here. We had a nothing. January was nothing, and February was nothing. Usually February is the coldest month. It was warm here.
Yeah,
really weird.
We had almost nothing until the 1st of February. It's
Yeah.
been a beautiful winter. And now that it's March, it's springtime. So I'm waiting for the spring.
I know. Yeah, exactly. And so now when things should be winding down, they seem to be winding up. I mean, we got snow all the time. It's really cold. My daughter's been really wanting to learn to skate. And the lakes just got some of the lakes are just starting to be where I live is lakes everywhere. So you don't have to drive far. There's a lake like 5-minute walk down the road. That one's not safely frozen yet, but there's one about 10-minute drive that it's more like a tiny pond, so that's frozen. But that just happened. Like we literally could not go skating or ice fishing or anything all through February. It's really weird.
Well, the Ottawa Canal, which is used for skating, right? They turned the whole thing into a big skating rink. I don't think it's been open yet.
Wow, that's
at least a couple weeks ago, they still weren't open, and they didn't think it would ever open this winter because it just wasn't cold enough.
My wife went to Carleton University in Ottawa, and she always talks about skating on the canal. And I mean, some people skate to work. They literally that's how they get around, because you can just fly down that thing.
Yeah.
And she mentioned skating at various states of inebriation, let's put it that way. That was back when you didn't have to wear helmets or anything. The world was just crazy and wide open. Do whatever you want. Who cares? Well, speaking of weird winters, we're going to be talking a little bit about winter effects and that sort of stuff. So I guess we should get right at just before we start. We're talking about this book, Plant Science. This is a book that came out, I think this was last year that this book came out, right?
Yeah.
You sent me a
about
copy.
A year old.
Great book. Recommend to anyone. Have a good read. I mean, we've covered a lot of it in the podcast, but really, this is just a smattering of little bits. There's way more in the book than what we've talked about. And you got a new book out?
I do. It came out for Christmas, and that's Compost Science.
Great.
For gardeners.
For gardeners.
Yeah, the whole series is for gardeners, and this is Compost Science. And of course, it covers everything about composting, including vermicomposting and bokashi and ecoenzymes and everything. Gives you a full view and helps people decide which composting system is best for them.
Right. Yeah. No, that sounds great. But getting back to this book, let's wade back into it. So I can't remember. I just got to get my numbers right here. But we're on chapter 3, right? Chapter 3 is stems.
Oh, it could be. Sounds familiar.
Yeah, no, it's right. Chapter 3 is stems. Okay. So first, I wanted to just get you to explain to the viewers the difference between talk a little about buds and terminal and lateral buds.
Yeah. So buds are really critical for all plants because that's where cell division is happening, right? I think some people think that, cell division is happening sort of all over the plant, and it doesn't. It only happens in certain spots on the plant and the buds is one of them. The very top tip and the buds cells are actually dividing, and those cells can then become fruits or flowers or stems or leaves or whatever the plant needs, right? So that's a really critical part. These buds, they develop at the very tip, and that's sort of the important bud on most plants. And then they also happen usually in the leaf axils,
Right.
and they happen along stems. So depending on the plant, you have more or less of these buds. Sometimes you can see them, sometimes they're completely hidden and you can't see them at all. And the plant has them sort of, you can think of them as being hidden underneath the outer layer of the stem, and it's waiting until something happens to the plant. And if it needs those buds, it activates them and they start to grow. Right? That's one of the reasons why if you can come along and say a sugar maple tree, you can cut it to the ground and it will grow again.
Yes.
You think you killed it, but there's hidden buds down there that you can't see. And once you cut the tree off, it starts to grow. Right.
I often wonder with like tomato, right? Because they say for certain kinds of tomatoes, I think it's the indeterminants, that you shouldn't, I mean, it's got all these buds because you get the main plant, you get these stems, and you get these extra ones, and then but you should be taking off all these little extra growths to get sort of optimal tomatoes out of your tomato plant. And they've never seemed to develop a tomato that just doesn't have that tendency,
Yeah, well, they're vines, right? And so what happens is they'll make branches, and then all the branches have buds on them, and they'll make branches and more branches. And if you leave them all, you end up with a really large plant. Excuse me. What's interesting with tomatoes is whether or not you should actually pull those suckers off, whether you should reduce those. And it really depends on what your goal is. So
Right.
if you want the maximum poundage of tomatoes, actually leave it all. You don't have to sucker it. You'll actually get lots, but
Yeah.
you tend to get smaller tomatoes.
Yes.
And you get them later in the season. So if you're in cold climates like you and I, we want early tomatoes. So suckering will help you get early tomatoes.
Yes.
And most of us want larger, juicy ones. We don't need large numbers, but we want good ones.
Yes.
And that's another reason we sucker them.
Right.
But you don't have to.
Right.
The plants will grow just fine.
Yeah, it's not required.
No.
Yes. No one's suckering anything in the woods, and the woods come back every year, and the birds find their fruit.
That's right.
Now, you talked a bit about in this chapter about overwintering. Or have we finished talking about buds yet?
Well,
Sorry.
There's lots to say about buds, so we can do a program on it. But one thing that I think is important for people to understand, especially if you're doing any kind of pruning, is that top bud is a special one, and I call it the king bud. And it actually produces a hormone called auxin, and it sends it down the stem. And that top bud actually prevents the buds lower down from growing.
Oh.
Right. So they're there, they're immature, they're sitting there, but they don't grow because they're getting this auxin from the top bud. Right. I call him the king bud because he doesn't want anybody else to become a king.
Right.
So he actually controls the bud growth lower down. So what happens when that top gets cut off? Well, he doesn't produce hormone anymore because he's gone. Right. So now the lateral buds, the buds below the cut, they start to grow because they're no longer held back.
Right.
And then these new buds, they compete with each other and they all want to become king buds.
Right.
And most of the time, one or other will become the largest growing bud, and then that will take over, become the new king. But in other cases, like if you did this with a tomato plant, you probably have 4 or 5 of these buds all growing, and they all grow. Right.
Yes.
It sort of depends on the type of plant, but knowing that is really important when you're pruning. So you know that when you're cutting something and pruning, you're always creating these new buds to grow. Right. And most of us go out to prune to keep things small, to keep them from growing. But pruning actually does the exact opposite. We usually, when we cut off one bud, we get 2 or 3 new ones growing. So pruning actually increases the amount of growth.
Right.
It doesn't stop growth.
Right, right. Yeah, I guess you're communicating with the plant, right? You're
Y-
changing the way the plant informs itself of what to do.
That's
Uh,
right. Yeah,
yes.
you've messed up its system. So now you got a whole bunch of these buds growing. And we can use that to an advantage if we want plants that are bushier and wider, right? We come along and we top them, and then they grow wide. And sometimes that's useful even for vegetables. So we can top them, and you just now you make this bushy plant. For instance, peppers, right? A lot of people will start their peppers indoors, and once they get to a certain height, they'll pinch the top off.
Mm,
They're taking away that terminal bud. And what happens? A whole bunch of side buds grow. And you end up with a seedling that is much bushier, has
mm,
more branches, and will produce more fruit, more
mm,
flowers, and more fruit on that bush. Right? It'll be a little shorter and bushier, but
right,
the yield goes up. At least that's what some people think. Okay.
right,
I'm not certain that that's true, but
right.
there are a lot of people who are sort of who spend all their life growing peppers, and they're experts at this, and that's what they do. They top it, and so they get bushier plants and more fruit.
Yeah, no, I've definitely read that. I'm sure if you have a hot enough summer and enough warm sunny days and enough time and all that sort of
Yeah,
stuff, because yeah, it's just kind of the idea of turning one pepper into two.
yeah,
That's the concept, I guess, if there's enough time for that to happen.
yeah, yeah.
Yeah, yeah. I remember, I think it was Lee Reich. I had him on to talk about tomatoes, and I was asking him about topping and determinants
Mhm.
to hasten a harvest, and he was skeptical if it had any effect at all. Uh, you know, so
Yeah. Um, I mean, I do that in August because I know that any flowers I get in August aren't going to mature.
that's what I was telling him. Yes.
So you might as well cut that off. Whether it makes the lower down fruit mature sooner or larger, I don't know.
Yes, exactly. You just know that those ones have no future, right?
That's right.
Yeah, the ones you're taking off aren't going anywhere. Nothing's happening there.
Yeah.
So if there is some, you know, limited zero-sum game, limited resources in the plant, you don't want them being invested in the flowers that have no future. But whether it affects, uh, you know, whether that accelerates the ripening of the remaining fruit,
Yeah.
I don't know. Makes me feel good.
Yeah. In theory, it works.
Yeah.
I don't know if in practice it actually makes much of a difference.
Yes. But at least you feel like you have some agency.
That's right.
I was going to ask about overwintering. I mean, this sort of just straddles a couple chapters, but just in terms of of stems and overwintering, I mean, you described two ways plants have perennials, right? If we're talking about overwintering, we're talking about perennials. There's two strategies they have for overwintering. One is just being a woody plant. We'll talk about that later.
Yeah.
But what's the other strategy?
Well, the what most perennials do, herbaceous perennials in the garden, they go underground, right? So they're genetically programmed to grow well until late summer, early fall, and then they give up the top part. And they say, well, okay, I'm not going to support top growth anymore. So growth stops, there aren't any new buds and so on. And the food that's in the green material above ground all gets sucked down into the root system or into
Hmm.
some sort of a tuber system or into a bulb or something.
More like in
Most,
your rhubarb sort of thing.
yeah, the rhubarb has a big tuber. I'm
Yeah,
not sure it's officially a tuber, but there's some
huge
root
thing.
growth that expands, right?
Yeah,
The potato is one of those structures. And all those underground structures are designed to hold the nutrients for spring when the top part starts growing again.
yeah. Yes.
And that's a good strategy because it doesn't have to overwinter. And I think one thing gardeners don't really appreciate is that, things above the ground is what we experience, and it gets really cold. But an inch below that surface, it never really gets cold. Okay,
Hmm.
it does freeze, and it goes down to a couple degrees below freezing, but it never really gets really cold, right? And the reason is that there's heat coming up from the center of the earth, and it comes up to the surface of the soil, and then it escapes into the air and gets lost. But that heat is continually coming up. And so things that are a couple of inches below the surface of the soil are actually pretty warm in the winter.
Right.
The
Yeah.
soil does freeze around them, but they're able to withstand that. And they just overwinter that way. And then
Right.
they'll wait till things warm up in the spring.
That's right. And they don't, I mean, we'll talk about this in the environmental factors chapter, but they don't experience the extremes that everybody else is experiencing, because they're in the basement sort of thing.
Yeah.
Um, so, but when do you decide? So like you've got you've got you've got rhubarb, or you've got some sort of herb or something like that, or rose, right? Um, when do you decide to? I often wonder about my herbs, right? So I've got sage and oregano, and a number of other things, but just keep it simple, talking about sage and oregano. I always wonder if I should cut it right down to the ground or leave like the whole plant and just let it, almost like be its own mulch sort of thing, like leave the whole thing and then maybe cut it in the spring. Even in the spring, I'm like, how much should I leave above the ground for something like a sage or an oregano where they, because I notice when you cut it back, if you just leave it, you don't get growth everywhere. There's
Right.
growth somewhere. So, I mean, how do you decide how far down to cut something like that? Does it depend on the plant or?
Yeah, it depends on the plant. So there's one thing that confuses a lot of gardeners. And the reason there's confusion is because nurseries lied to gardeners. That's why we're confused. So something like sage, for instance, isn't a herbaceous perennial. It's actually a subshrub. Okay?
Ah,
Same with thyme, lavender, Russian sage. These are all shrubs, and we call them subshrubs, which just means that they're small shrubs, but they're actually woody plants.
like a tree.
Like a tree.
Yeah.
But in the nursery, they're all sold with the perennials. They're right beside the hostas. So gardeners take them home and treat them like a perennial. So if we take a hosta, for instance, you can cut that down anytime. You're not going to do any damage. Now, it is better for the environment if we leave everything in the fall and cut it down in the spring.
Hmm.
And in the spring, we can cut it right to the ground because all of the new buds are underground. Okay, it doesn't matter how far down we cut them. So it's
You're
not
talking about a herbaceous perennial right now.
herbaceous. Yeah,
Okay.
this is herbaceous, right?
Yeah. Yeah.
But when we're talking about woody plants, we can't do that. You can't just cut them to the ground because they may not have dormant buds there.
Hmm.
So the best thing with herbaceous, with woody plants is you leave them and come along in sort of mid-spring once growth starts. And then you can cut them back to the lowest growth that you have.
Right.
If you cut below that, you may kill the plant.
Right.
So I leave those, and then it's quite late until they come out because a lot of them are warm climate growers. So they take their time in spring. They want to get some good warm weather. And I wait until I see the new buds actually leafing out. And then I come along and then I can decide how high I want the plant, but I don't go down to the point where I cut all the new growth off. I have to leave some of that new growth.
But you do cut it, so you don't leave it as high. Like, so the one thing you could do is like see where where the growth, as high as the growth is, and then everything above that goes. You're saying go down and, don't go all the way to the bottom, but go down to the bottom and then come up a little bit sort of thing. Is that what you're?
Well, that makes sense from one point of view. Now, you don't have to do that. You don't have to do any pruning. Just leave them.
Yes.
Right?
Yes.
And they will grow. The problem with a lot of these subshrubs is that they get kind of leggy, right?
Yes.
So if you don't prune them, in a year or two, you've got these 3 foot of bare stem that does nothing, and you got growth on top, and they just don't look good in the garden.
Yeah.
Right?
So I also find like, and the reason I have this dilemma is when you're harvesting the herbs, right? You're getting all this woody crap in there and not the good sort of lush green stuff. So there's all the sorting you have to do to actually get the herbs out. Because I take a good portion when the plant's at its peak. I take a good portion of the foliage away and dry it and put it all in jars, and that's my herbs for the year. But yeah, the dilemma is like if I don't prune them, I don't think I'm pruning them down as far as you're suggesting.
Yeah.
And then I get all this crap in there that it's just non-herb stuff that needs to be sorted out.
The plants do better and certainly look better if you prune them down to a few growing buds
I
and
see,
then let them grow from there.
because that's all new.
Yeah.
Okay.
Again, that's, you know, in nature, nobody does that. So they get long and lanky, nobody cares. But
That's right.
we want our plants to look a little nicer. So pruning back does help with that process.
All right, that's good advice. Another thing about stems, and I mean, I think some gardeners know this, but not every gardener knows this. So this is something you notice in the woods a lot, and you can use it for your advantage sometimes. But so why do plants get? I mean, this is transplant season, so people are going to experience this. Why do plants get leggy?
Why do plants? Well,
What does leggy mean first, just for those that don't know?
okay. Yeah, leggy doesn't mean they develop a bunch of legs. That would be kind of cool, but so leggy just means that they get taller than they should be, and because they do that, the stems are kind of weak. So you
Right.
get these tall growths that are weak, and you get some leaves quite high up, and it just makes for an unhealthy plant.
Right.
In nature, plants don't get leggy normally, right? Because they're getting lots of sun, and they also grow cool. So most of these seeds are germinating fairly early in the season when it's still cool. But then gardeners come along and mess it up, right? So they take these seeds and they bring them inside. A lot of people use heating mats to germinate them, and then they leave them on the heating mat. So they're actually growing them warm. And I think people think that, you know, all these plants we're growing need to grow warm, but in fact, they grow better cool.
Right.
So use the heating mat to germinate if you like, but as soon as you see any green, take them off the heating mat and grow them cool. So heat is one problem. And the second one is the amount of light and maybe the quality of light, but mostly it's the amount. So a lot of people put these things on a sunny window, but you have to remember that what we think is sunny is not sunny compared to what's outside. So we're trying to grow these seedlings in a really low light condition. And what the plant does, it germinates and makes a little spike up and goes, well, where's the sun? Where's all the light? Well, I better go find it. So it starts growing really tall and it elongates. It's trying to reach the light.
It thinks it's competing with foliage above it, like it's going to punch through some sort of canopy.
Yeah, they're, you know, the neighbor plants are shading it. The shade, it just reaches for the sun. If it gets more light, then they'll be shorter. If you don't give them enough light, they get taller. And the light is the major reason you get leggy seedlings.
Right.
And most of us in the home, we just don't have good lighting systems for growing seedlings.
Right.
So the trick is don't start them too early. Give them as much light as you can and try to grow them on the cool side.
Should you be okay with a south window? Like, is that?
I give them as much light as you can.
Right.
Now, there is a potential problem here is that if you germinate them somewhere where it's dark, like your basement, and then you put them in that sunny window, they'll get fried, right? They get too much sun too quickly. So you do have to get them accustomed to that light. But once they're accustomed to it, they can take full southern windows because that same seedling, you could start outside in something like winter sowing, for example, where they get 100% sun all day long. And what you end up with is really tiny, tough little plants.
Yes.
Right? The first time you see them, you think, oh, geez, these aren't growing right. They're only like, you know, quarter-inch tall, but they're tough and they're growing the way they do in nature, right?
Yes.
We're used to seeing these tall, leggy little things. So,
That's right. I've done experiments with doing that sort of thing under hoop houses with tomatoes, where I stick the seed in the ground and at the beginning of May,
Yeah.
and uh, when everything goes right. I mean, every once in a while we'll have a May where it gets so cold everything dies, even inside a hoop house. But when everything works out right, um, you could have a seedling you started outdoors in a hoop house in May, and another seedling you started 1st of April in a window in your house. And the outdoor one actually might outperform
Yeah.
the one, even though it's been growing half the time, because it's been getting full sun and real soil conditions, and sort of all just, it never had to, it had infinite capacity to expand its root, all the water it ever wanted, all the sun it could ever take,
Yeah.
all that sort of stuff going on.
Yeah.
But it's a gamble. For every year I've had amazing success, there's been years where they all are just vaporized in one night, right? And you think, God damn it, they're all dead, Or there's one day where you forget to vent the thing
Yeah.
and they're all destroyed, right? Completely to just because it was like 55 Celsius in there, some crazy heat like that.
Yeah.
Okay, now one more thing about stems, and that's talking about vines. So there's a
Yeah.
neat thing in your book where you talk about, do they, whether it's the tendrils on peas or just a plant like a bean that tends to vine like this. And there's some people say, oh, they grow kind of like flushing a toilet. They go this way in, the northern hemisphere, and this way in the southern hemisphere,
Yeah.
and that sort of thing. Can you give us some clarity on that? What's really
Sure.
the case?
Sure. So most vines will twirl around something, right? That helps them go up
Yes,
another plant. And it turns out that, if I remember correctly, about 80% of them go one way and the other 20% go the other way. It doesn't matter which hemisphere you're in, they're going to go, if it's a clockwise vine, it will go clockwise.
right.
And it is handy to know which one's which, because a lot of us gardeners will help it along, right? The
I do that.
vines tend to grow up sideways and they're looking for something, and we push it back on where it's supposed to be and we help it go around. But if you turn it the wrong way, then the vine has to kind of correct itself to go the right way. So we
Yes,
learn which way these vines go. Now you can look at the older stems farther down if it's an older plant and watch it, and you'll see how it's twirling. But yeah, it's handy to make it twirl the right way. I mean, you won't harm the plant if you twirl it the wrong way.
just a second. God, this always terrifies the hell out of me.
If suspicious activity,
Good God.
is described as white, with a bald head and dark brown beard, he may not be wearing
Oh, this sends chills up my spine. There's some guy running around some town with a knife. It's not my town, thank goodness, but yeah.
Huh.
I gotta say okay, or it'll keep doing it. Yeah, but I don't know if you get these, but we get alarms. There's some guy running around with a knife on about, I don't know, 30 kilometers away.
Yeah.
Yeah, that's not good.
Well, turn your lights off, and maybe he'll come in.
Well, in the middle of a blizzard, but anyway. All right. So yeah, I find I'll often do this with my cucumbers. I try to get them, but I'm probably doing it the wrong way. So I think in your book you say most of them have a tendency to go one of those, like something like 90% of the plants go, I can't remember which way it was, but so buy that book. But 90% of plants tend to go one way. Doesn't matter where they're growing.
That's right. Yeah.
And it's the opposite to what if you're right-handed, I think it's counterclockwise, because I think you said right-handed people tend to twist clockwise, and most vines don't go clockwise; they go the opposite.
Yeah.
I think. Don't quote me on that. Here, read the book or Google it or whatever. But yeah, it's not like the toilet.
Well, even the toilet thing is a myth.
What? I didn't know that.
Yes.
Jeez.
No, your day's really messed up now.
Oh my God! I thought there's an episode of The Simpsons where they talk about that and how they in the American embassy in Australia, and they have this unbelievably complicated toilet that flushes the correct American way. Funny episode. Uh, anyway, it's a huge machine attached to the toilet to make it flush the other way. Uh, anyway, okay, leaves.
Leaves.
So one part of the chapter you talk about damaged leaves and how people, might look at damaged leaves to diagnose what's wrong with a plant. And
Okay.
I think you caution against trying to play doctor using that indication.
Yeah, well, I guess it depends on what the damage is, right? So there are lots of memes out there that tell you to look at the leaves, and based on coloration and whether it's yellow or whether the veins are green and the center part is yellow and so on, you can determine deficiencies, nutrient deficiencies. Okay, those are all wrong. Okay, you cannot look at a plant and figure out what the deficiency is.
Right.
Well, there's probably one or two exceptions, but for a general rule of thumb, you cannot do that.
Yeah, yeah. You'll see this on the garden groups on Facebook all the time. Hey, what's wrong with my plant? And I'll have a picture of their plant. And everybody will say, oh, you need calcium, you need this, you need that. Just based on looking at some picture. Yeah.
That doesn't work. It's all over the internet. It just doesn't work. Now, what does work is if the leaf is actually damaged, say, by insects who've been chewing on it, or diseases, and you see damage from those two things, then what you're seeing helps you identify what is doing the damage.
Right.
Now, it may not be easy, but like leaf cutter bees, for instance, are very distinct. They make these round circles at the edge of a leaf, and you can see that.
Right.
Some
Yeah.
some fungal diseases will make quite round holes. You'll get a brown spot. First, it goes kind of yellow spot, and then it goes a brown spot, and then the whole thing falls out, and you end up with this round hole in the middle of your leaf. And so those sorts of things are quite good for diagnosing pests and diseases.
I think flea beetle's another obvious one.
Yeah.
But I think there's another thing you said in the book about your inclination as a gardener is to remove damaged leaves.
Yeah.
Okay, so talk about that.
Yeah, so this is very common advice, and I even see it all over government websites in the US, right? Extension offices that are generally giving you good gardening advice.
Yeah.
And many of them will tell you to remove these leaves. If your rose gets black spots, start removing the leaves. Mildew, start removing the leaves. And don't leave them in your garden. Put them in the garbage bin. Don't compost those, because then you keep the diseases. And for the most part, that's actually bad advice. Okay, you're not going to stop these diseases. By the time you see them, they've been there for quite a while, and they're everywhere. So by the time you see mildew on a leaf, it's already been there probably a month, the spores. And the spores are on the leaves and stems, the soil, they're everywhere. Pulling off one or two leaves is not going to make any difference to the plant. Now, there is a point where it may make some sense. So we have this big leaf, and we start seeing some mildew along the edges. What I tend to do is leave the leaf, because most of the leaf is green and it's still working for the plant, right? If it's
gathering
green,
energy,
it's photosynthesizing, it's making food. We want to keep that. Now, once you reach a point where 80% of the leaf is covered in mildew, that leaf is no longer very productive. And pulling it off at that point isn't going to harm the plant, right? But you might as well compost it, because now you have mildew everywhere. So yes. I think that advice is bad. In fact, I just this weekend talked to someone who teaches horticulture, and I asked him about it, and he agreed with me. He says, there's no point removing all these diseased leaves from your property, because everything is diseased by fall. If you remove every piece of plant material that was diseased, you wouldn't never have anything to put in your compost pile.
Well, right? I was like, there isn't mildew in your compost?
That's right. I mean, I think people, we don't understand that these spores are so small, and the huge quantities, they're covering everything in the garden. Right? Yeah. So bottom line is, don't really worry about it.
Yeah. I remember I had a guy come to drop some wood chips off at my house, and they'd been sitting in his truck for a while.
Yeah.
And I was helping him, and I went into the back. He's got a box truck,
Mm.
and I went into the truck. He said, "Don't go in there. You got to wear a mask because
Yeah.
it's all this stuff. And if you breathe it, he said you'll feel like hell for days. And it's some sort of mildew, mold and mildew inside the wood chips, just naturally there.
Yeah.
And I mean, I'm going to spread it all over my garden, and everything's going to grow great, So,
Well,
but don't breathe it.
his advice was actually good,
Yes.
because when you have wood chips sitting for a while, they get a lot of fungal growth on them, and they make
Yeah.
lots of spores.
Yeah.
And spores can make you sick. They can make you very sick.
Yeah.
They can irritate your eyes, and so it is recommended that you wear a dust mask if you're
Yes.
working with wood chips a lot. Like if it's a couple of days a year sort of thing, I wouldn't worry too much. But if you do this on a more regular basis, it's actually very good advice to keep those spores out. Right?
Yes.
It will affect our lungs.
Yes. Especially shoveling it inside of a box truck.
Yeah.
It's just everywhere, right? Okay, so there's that. Now, so I mean, the advice is, yeah, it's a damaged leaf, even if it's been attached by a pest or something like that. This is still a photosynthesis machine, and so as long as, I mean, it's one thing if you want it to look pretty or you're taking pictures or something like that, but
Right.
generally speaking, if your whole point is to get as much energy into that plant as you can, don't take away the energy system, right?
Yeah. My general rule of thumb is if it's green, leave it on the plant.
Right. Yeah. Yeah.
Once it goes yellow or brown or something, you can do whatever you want with it, because it's of no use to the plant now.
Yes.
But if most of the leaf is green, leave it.
Okay. So another thing you talk about leaves was how they produce natural pesticides.
Yeah.
And I think you mentioned that's a function of predation. You get a leaf getting bit. So anyway, I'll let you talk. What's the deal with leaves producing natural pesticides?
If we think about a plant that's sitting somewhere and a pest comes along, what can the plant do? It can't do anything, right? It can't run away, it can't duck, it can't go hide, it can't do any of these things that animals do. So the only thing a plant can do is produce chemicals to persuade the insect not to eat it, right? So it turns out that plants are fabulous chemical manufacturers. And part of it is their biology as well, but they make thousands of different chemicals. Many of them are pesticides.
Right.
Okay? For instance, you may have heard of using nicotine in your garden as a spray. I mean, this was something that was common 30, 40 years ago, and then people learned that nicotine is actually almost deadly if you spray it on yourself, so people stopped doing that.
Right.
But people used to actually chew tobacco and get the juices from it and make a pesticide, because nicotine is a very potent pesticide.
Right.
Well, why does a plant make nicotine? Well, it keeps pests from eating it. It's as simple as that. Our milkweed plants, for instance, where the monarch butterfly goes on, okay, almost nothing eats milkweed, because that latex juice in it is full of chemicals that other insects have learned is deadly. They don't go on milkweed.
Right.
It just turns out the monarch butterfly caterpillar has adapted so it can digest this stuff.
And nothing eats that caterpillar.
Right, because it's full of these toxins.
It's deadly.
So what I find really amazing is that many people are so deadly afraid of synthetic pesticides, and yet they have no problem eating a carrot. And
Right.
the carrot is full of nasty pesticides. And in fact, if we look at the natural carcinogens in plants, they're 99.99% are natural and 0.001% are synthetic.
Right. Right.
And we eat actually quite large quantities of these things every day. And these are known carcinogens and known pesticides, and we eat them all the time, and we think it's good for us. Okay?
Right.
And it is, because our bodies over the millions of years has adapted so that we can handle these things.
We're like
Now, the
monarch
one thing-
butterflies.
yeah, the one thing I have to point out is when I say they're full of these toxins, that's true, but the quantities are very low.
Yes.
Right. So when you eat a carrot, yes, you get some of these toxins, but the amounts are so low, it doesn't harm us. Our body is able to take care of that. Right?
Yes.
And that's the thing that I think a lot of people don't realize. But that's how plants defend themselves.
Oh, I
right?
think like a great example is spinach, right? Oh, we always think spinach is really, really healthy.
Yeah.
And it's probably like you plant a bunch of things in early season, everything gets like I plant spinach and kale at the same time. Okay. The kale gets the crap kicked out of it by everything. Slugs, flea beetles, you name it. Everything's at the kale. The spinach is like almost pest free.
Yeah.
And it's pest free because it's full of oxalic acid. I'm going to guess that's what's the active thing.
Yeah.
And you have and same with Swiss chard, really, really sharp taste of the Swiss chard. So
Yeah.
we're eating, I mean, I eat spinach in a salad fresh. I don't even cook it because I like it so much. You know, and even though it's got so much pesticide in it that most pests won't even touch it.
That's
You know, same with
I think the important thing for people to understand is like we're talking about organic spinach,
yes,
right? That's full of pesticides.
natural. Yeah.
Yeah, and it's just the way plants are, and that's how they defend themselves.
Well, it's the other thing I've done videos on this about how awful kale tastes in the summer, right? Because I think it must be just chock full of it tastes very bitter and very sharp and sort of not at its best. And then as you get into the winter and you get the frost and that sort of thing, it just the whole chemistry of the plant fundamentally changes.
Yeah.
And what do you know? In the fall, there's less pests going around. It's cold at night. It's zero. There's no pest damage at night because it's 0 Celsius at night. And well, lo and behold, and there's frost and things like that. So lo and behold, your kale starts tasting. It's the same kale, right? I mean, it's not like it put on new foliage suddenly in November. Right? It's the same foliage that was there, but it's chemically, like literally, the chemistry of the plant changes so dramatically that it goes from being very hard to eat to tasting really good. You know,
Well, I don't know if I agree with that, but
you're not a fan of the kale.
it's edible. I say it's become edible.
I can tell you as a connoisseur, and I don't care what variety of kale it is. It changes, and my whole family, we all eat it, and we really, really do not enjoy it in July, August, and even, you know, but once you start getting those cold days, October, November, I mean, I can just watch my kids. They'll eat twice as much. My wife will eat more, right? Because it tastes better.
Yeah.
Okay. Last thing about leaves, dropping lower leaves.
Okay. So what a plant does, again, plants, you know, I hate using the word think, but plants are actually kind of smart in a way. But when I say that, I don't imply that they have any real intelligence.
Yes.
But their biochemistry has been designed to make them efficient. So if we think about a plant that gets bigger over the summer and the top leaves get more and the side branches come along, and well, what happens to those early leaves? Well, there's two things that are important to understand. Is that one is that leaves have a life cycle, so they get old. Okay, I think we tend to think that once a leaf is formed, is kind of there forever, and that's not true. It goes through a life cycle, just like people, right? It's a young leaf, and then it's a young adult, and it's really productive, and it's doing everything right, and then it gets old and becomes less productive, and at some point the plant says, I'm going to get rid of this, right? And it will drop that lower leaf. The other thing that happens is as the plant grows, those lower leaves don't get enough sun. Remember, we talked about these leggy plants. Well, these early leaves are the same problem. They're now shaded by all the leaves above it, and they're not productive. They don't get enough sun to produce enough food for the plant to keep it.
Mm.
There is a biochemical process that simply says, okay, we're not going to support this leaf anymore. We're not sending nitrogen to this leaf. In fact, we do the opposite. We're going to suck out all the nitrogen and sugars and anything we can use out of this leaf. And that's usually why it turns yellow, and then it falls
Oh,
off. And
so it's being cannibalized in a sense.
it's being cannibalized.
Ah, yes.
In fact, a sign of nitrogen deficiency is that your new leaves are nice and green because they're getting enough nitrogen, but your old leaves are dying back sooner than they should.
Oh,
Right? The plant is actually it doesn't have enough nitrogen to support the top growth. So it takes it out of the lower growth and sends it to the tip.
mm,
And says, I only have so much and I need it up at the tip because that's the important part. That's where the fruit's going to be, the flowers, right? A plant's goal is to make seeds. That's its
yes.
goal in life. So
Yeah.
it's trying to support that process and says, okay, I can't afford to keep these lower leaves, so I'll get rid of them. So
Right,
that
right.
is a sign of nitrogen deficiency, but it's also a natural process. So once a leaf is a certain age, the plant just gets rid of it, right?
You're fired.
You're you're too old. Get out of here.
Right. Yeah, wow. Well, that is very efficient. Yeah.
Yeah.
Yeah, it's just the plant's it's almost like there's a CEO at the at the head at the helm.
Yeah.
Uh,
But again, it's really important that people understand there's no brain here. There's no logic. All of these things are driven by fairly simple chemical processes.
mhm.
Now they're not simple, but they're simple reactions, just chemicals bumping into each other and reacting, and that's what causes all of this to happen, right?
Right.
Um,
All right.
no,
Now with flowers,
yeah.
what causes flowering? How do you, I got a plant and it's growing and it's adding stems, it's adding leaves, it's getting larger and it's getting larger. Let's say a pepper or tomato or something like that. Use a tomato because that's the example for our gardeners. Everybody grows tomatoes. I'm growing a tomato and there's no flowers. Well, what's happening when it starts? Why is it making a flower now when it wasn't making a flower before?
Well, you didn't put any Epsom salts in the soil.
Yes,
That's the
ah,
problem.
I also didn't put the antacid in the ground either. You know, you gotta have the Tums down there too, Rolaids or whatever. Yeah.
Anyway, we're kidding. Those are all mess, right?
Yeah.
we don't want our viewers to run off and buy Epsom salts.
That's right.
So most flowering is determined by two main things. One is the age of the plant, and the second is temperature and amount of light. So those three things are affecting the plant. So when plants are too young, they just won't flower. They don't have enough energy in the plant, and the genetics just won't start up to flower. So you need a certain size of plant before that happens. The second thing that's important is temperature. And for tomatoes, it's a good example. If your temperatures are too low, they just won't flower.
You mean soil temperature or ambient air temperature?
Air temperature.
Air temperature. Okay.
Yeah. Because tomatoes are warm climate plants, right? And they need a certain temperature before they'll initiate flowers. But we also have the opposite problem, that if it gets too hot, they stop flowering.
Mm.
So there's this sweet spot where they need a certain temperature to initiate flowering, and then can't get too hot. Now in zone 5, the hot is usually not an issue. We don't really get into that. But in hot climates in the US, yeah, you can get too hot, and in the middle of summer, your tomatoes stop flowering.
Mm.
The reason is it's too hot. And they will wait until the temperature drops back down, and then they'll start flowering again.
Ah.
Okay. The third thing that affects plants, and I don't think it affects tomatoes, but a lot of plants are affected by day length. So the one I used in my book is chrysanthemums. The other one that a lot of people know are poinsettia, right? They will only flower if the nighttime duration is long enough. Now, a lot of people say this is daylight. They need a certain length of daylight, so many hours of daylight, but it turns out it's actually darkness that they need. So if they're getting 10 hours of darkness, they won't flower. They need 12 hours of darkness. And that dark period triggers the biochemistry inside the cells to start making flowers.
Is that because at 12 hours it knows it's the solstice? Is that
No, the plants don't have a brain, you
it's the
see.
opposite? Equinox.
No.
Sorry, equinox. The wrong term.
It
But
it has to, again, it's a, I mean, it's elegant chemistry, but it's relatively basic chemistry. So what happens when it gets dark is that there are some chemical changes in the plant. It stops photosynthesizing, it stops making the proteins that photosynthesize, and it starts doing some other biochemistry. And there are specific molecules in there that start accumulating when it's dark.
I see.
They accumulate, and if there's only 6 hours of darkness, there aren't enough of them by the time the light comes, and they basically get used up again.
Oh, I see. I see.
But when you have 12 hours of darkness, there's enough of this to be
The
accumulated that
critical mass.
now
Yes.
affects the genetics of the plant.
Oh, I see. Right, right.
So it's a buildup of these molecules, and the light affects that. So after, if it's only 6 hours, the plant says, okay, I'm going to start photosynthesizing again, and that kind of erases all of these special molecules for flowering.
Oh, I see. That's
And
really neat.
so there's a system like that, and each plant is a little different, right? The 12 hours is sort of, applies to a lot of plants, but each plant has their own cycle that they're looking for. And in fact, some plants do want a light period. So some are light sensitive, some are dark sensitive.
I see.
So if you take something like the plant that we have at Christmas, poinsettia.
Poinsettia, yeah.
Right. So we take that plant and we give it darkness, but then someone comes in and turns the light on in the greenhouse. It can actually revert the flowering process because it needs so many days or weeks of darkness to actually initiate flowering. Okay, so it's waiting for, so let's call it a week of darkness, and then it starts flowering. And if we're up on day 6 and someone turns the light on suddenly, that's enough to stop flowering. In fact, there is some concern about cities that are too bright. So we take plants and put them in our landscape, and they're no longer getting a dark period.
Oh, because that glow. That's
because of the street lights are too bright for it,
I
right?
see, right.
And there are some plants that don't flower nearly so well now in the city because they're getting too much light exposure. They're not getting their long dark period, right? And in fact, I'm pretty sure in the book I talk about there's a little table, and there's different kinds of lights and which ones affect plants more than others. So for someone who is putting lights in their backyard, there's some are better because they won't affect the flowering period.
I see. Right.
Yeah.
That's really neat. Now, what about the idea of, you don't have enough blooms for whatever you're growing, so you decide to add some phosphate.
Right.
Is that a good idea?
Yeah, this is another very, very common myth. And in fact, you can buy products that are called bloom boosters.
Bloom booster.
And they have an MPK with a very high middle number. So I was looking at one yesterday, it was like a 10, 50, 10.
50.
Bloom booster, right? Because if you want flowers, you got to give it lots of phosphate. Okay? That's complete nonsense. Now, there is one case where it will work. So if your soil is really deficient of phosphate, it can prevent flowering, right? And so if we add some phosphate fertilizer, then they will flower because these plants were growing without the right nutrients.
Right.
But in most cases, the plants are growing with the nutrients they need.
Right.
And then adding excess phosphate is not going to make anything bloom. And it turns out in North America, at least, most soil has enough phosphate.
Right.
So we don't need to add phosphate to our soils.
Yes.
So nobody should be doing that unless they know that they have a deficiency of phosphate.
Right. A really unique situation.
Yeah.
In the soil.
But provided the plant is getting a reasonable amount of nutrients, adding fertilizer is not going to make it flower.
Right.
But adding fertilizer in a situation like a potted plant
Right.
that has been watered, for weeks and weeks with no fertilizer, and now it's really being starved, and you put on some fertilizer, you might see a flower spike come up because of that.
Right.
Here we have a situation where we have a starved plant and we suddenly fed it, right?
Yes. Yes.
Yeah.
That makes perfect sense.
Yeah.
There was one thing you talk about in this chapter that I didn't know about, and it really brought something into clarity for me, and that was your discussion about mast years.
Yeah.
So can you explain what that means?
Yeah, so a mast year is essentially a year when a plant has a lot of fruit developing. It's making a lot of seed. And that usually requires a lot of flowers, right?
Yes,
The
yes.
plant makes more flowers, they get pollinated, and they make more seeds. And that process for a plant takes a lot of energy. A lot of their internal chemicals and nutrients and sugars and everything go into making seeds. And making seeds is one of the most costly things that plants do, right? So it takes a lot out of it.
Right.
It's like running the marathon.
Hmm.
Day after a marathon, you don't run a marathon, right? You
Right. Yes.
rest.
Yes. Yes.
But particularly woody plants, they go on sort of a multi-year cycle. So when you see a woody plant do something today, it's it's a result of what happened to it over the last 2 or 3 years.
Mm.
Okay, could be even farther back than that. So I just heard about a case where some trees were starting to sort of die back and die out. And they finally figured out that the reason was that 10 years ago, there was a real bad drought. And the drought was so bad that the roots were dying back. They had a lot of insects on the trees. And then they sort of recovered and they sort of stumbled along for 10 years. And they finally said, that's enough. I can't go any further. Right. So it can go back several years. But as far as flowering goes, what we find with most fruiting woody plants is that they have an off year. So they're good one year, very little the next year. Then they have a good year again, very little next year.
I see.
And even when they're growing in good conditions and they have lots of nutrients and good soil and everything, they still kind of take a year off, right? It doesn't
Right.
mean you don't get any flowering, you just have a lot less the next year.
That's really useful for gardeners to know because like last year, I had an incredible blueberry crop.
Yeah.
I mean, I never had so much, right? And then, so you're saying it might be, irrational to think that's going to be the case every year. That if I moved all those blueberries, so they're not going to produce like that. I moved them all in the fall, so I'd be lucky to get anything this year. I've set my expectations very low. But let's say they'd stayed all in place and I just prune them a little bit, sort of thing. It wouldn't be. I would be setting myself up for disappointment if I expected it was just an amazing year. They're everywhere, right? So it's
And this lends to a problem that gardeners have, right? When we do things in the garden, we don't use controls. We go in the garden and do something, and then we watch and something happens. So, I did something in spring and suddenly I have a bumper crop and I say, geez, adding that beer to the soil really worked.
yes,
I got a bumper crop, right?
yes.
Well, next year you forget that and it didn't work so well, but you still told a lot of people on Facebook that it works.
Or your Epsom salt. I put some Epsom salts in my
Yeah.
blueberries,
Yeah.
and then in year two I don't get as much. So I put twice as much Epsom salts, and I kill the whole damn plant.
Yeah. Yeah.
Yes,
So when
exactly.
gardeners are thinking about what they do, that's why controls are so important, right? You have to compare one that's treated with one that isn't. And we have to think a couple years back, right? For herbaceous perennials, you kind of have to think certainly a season back, what happened in the spring or maybe what happened last fall. Woody plants is sort of 2 to 3 years. What happened over the last 2 or 3 years that may have caused this to be different?
Right.
It's not what you did last week.
Right.
Right.
Yeah. I mean, often I like to think of the plant as it's an energy gathering machine,
Mm-hmm.
and the fruit is energy. It's basically it's giving up energy, right? Because it's sugar, right? So, it's in any given year, it gathers energy and it releases energy in the fruit. But if it's gathering energy over multiple years, and it's, I wonder if the mast, are the mast years predictable, or does the plant respond to particular, like, in the wine industry, they say, oh, 77, that was a great year. So, did it just happen to be the plant's time, or is the plant responding to like, it just seems to know, no, when it's, this is a great, this is the year, to do everything, because everything feels like maybe the weather seems right, the ground feels right, the air feels right. Like, how is the plant, is it completely cyclical, like it's going to be every 3 years, or is it a accumulation of good years, or is it going to do this mast year when it just happens to be a particular good year to do it? Or does
It,
anybody know?
it's a combination of those things.
Okay.
So the year after a good year is almost always a poor year because the plant is drained, right?
Your marathon analogy, yes.
Yeah, but if for instance, the plant is ready for a good year and we have an early frost and it kills all the buds, then this year will be a bad year again. So it is somewhat environment controlled, right? In nature, those fluctuations happen less. In gardens, they can be more dramatic, right? Because you may fertilize one year and not the next year, or you were digging and not the next year. So, but in nature, it's mostly temperature that's controlling this, right? We have a late frost or an early frost or something that affects it.
Right.
But it's mostly cyclical. Yeah.
Right. Okay, that makes sense. All right, let's move on to woody plants here. So first, differentiate for us the difference, contrast a perennial and a woody plant. How are they not the same thing?
All right, so I like to think of these as growing throughout the summer. So in the spring, they both have buds and they both start growing. Now, on a woody plant, we generally see the buds because they're above ground. On a herbaceous perennial, they have buds too, but they're below ground. Right? But anyone who's say dug up peony knows about those buds. They're from the ground. So both plants are growing buds. They grow stems. They grow leaves. Everything's coming along nice and fresh. And then somewhere around the middle of summer, the two plants take a different approach. So the herbaceous plants, they start saying, okay, it's late July, August, and I'm not going to keep all these leaves up here, and I might as well start shutting things down. And I start prioritizing my roots, and I start moving things from the top growth into my roots. I stop growing the top part, so I don't make new leaves. I don't make new buds. I don't make a lot of dormant buds because they're useless up there, right? So herbaceous plants have very few dormant buds, and they start this migration towards winter by dying back.
Asparagus would be another good example.
Asparagus, sure, anything that's herbaceous. Now, they do form the buds underground, right? So that part is happening, but not above ground. Woody plants take a different approach, and they're coming along in July and they're saying, okay, I'm going to keep everything above ground, but it's not going to survive the winter if I don't do something here. So I have to change the biochemistry. I have to change the process. So woody plants go through a hardening off process, and those stems go from softwood to semi-hardwood to hardwood. And that's a biochemical internal process that changes both the inside of the stems and the outer bark of the stems, and it's getting ready for winter. Right? It also does things like removing some moisture out of the cells in the plant. By removing moisture, it actually increases the concentration of sugars, and that acts like an antifreeze in those cells. So it also comes along and says, okay, let me make some buds that I'm going to use next spring, right? And I need those. Things like deciduous trees, they go along, and at some point, and this is again temperature and light dependent, they say, okay, I'm finished for the year. I'm going to take all the nutrients I can out of my leaves and send them into the plant. And that's why the leaves go yellow and they fall off.
Right.
It's not because the leaves got cold, and it's not because it's winter. It's because the conditions were such that the plant has pulled all the nutrients out of those leaves, and the plant actually closes off the cells that are between the leaf and the tree, and it abandons them.
Right. So the plant
So-
eats the leaf
It,
in a
it
sense.
sort of sucks all the good
Yeah,
stuff
yeah,
out of
yeah.
them and then throws the rest away. Yeah.
Yeah, yeah. And there's some I went mushroom gathering with a guy this year, and we were on beech trees, and they don't do that. The beech hangs onto its leaf because I guess, and he was kind of explaining what you were explaining there, but it doesn't do that for some
Well,
reason.
it sort of does. It
Okay.
still takes the nutrients out of the leaf,
Yes, yes.
but that there's a barrier between the leaf and the stem, and that doesn't seal off completely in the beeches.
Yeah, yeah.
So they hang on all winter long.
That's right. And he took me, what was it, oyster mushroom.
Hmm.
He's saying
Yeah.
like this is a good one to gather because the beech tree is so because I mean, I know this guy that had this incredible knowledge of mushrooms, and I'd see him. Oh, look at that one. That's not look good. It's like, no, that one will kill you. Look at that one over there. It's like, no, don't even touch that one over there. They all look great to me. They all look like great mushrooms. But you say like the beech tree, the oyster mushroom looks very distinct, and the beech tree is the only damn tree with leaves. The leaves are dead, but they're still so it's easy to identify, right?
Yeah.
It was really neat.
Yeah.
Anyway, getting off topic here. Okay, so you covered a few things there.
So that's the main difference. The woody plant keeps all the top growth. Now, though, there is a myth that I always believed, and that is that in the fall, these deciduous plants take all the nutrients out of their leaves and send it down to the roots, right? And then spring, it comes back up the tree again. And that's how we make maple syrup, but we collect the syrup coming up. That's actually not true. So most of those nutrients and sugars and everything stay in the woody part above ground. Some is sent to the roots, but not too much. Most of it is up there. And that actually makes a lot of sense because in spring, these buds grow very quickly. And if the tree was, 50 feet tall and it had to push the sugar solutions all the way up the tree to that bud near the top, it wouldn't get there till July.
Right.
And yet on a tree, all those buds open at the same time. And the reason is that right behind that bud is a sugar source. That's where the tree concentrates it. And so it's ready to pump it into the bud and get it growing as soon as spring arrives.
Well, and I seem to recall in the chapter you discussing like also, so the tree stores sugars and other chemical compounds in its foliage and its stem. But it dehydrates itself, and you alluded to this earlier, and all of this allows the tree to kind of have an antifreeze effect on the above ground foliage, so it can take. Can you talk about that a little bit about this whole surviving the winter thing?
Sure. You have to take a class in chemistry to understand this.
Right.
It kind of works like this. So when we have a solution with chemicals in it, that solution generally freezes at a lower temperature than just water alone. Okay, so if I take water and make an ice cube out of it, it freezes at the freezing point. But if I put some sugar in that water, it won't freeze. Okay? You might know that if you take alcohol and put it in a freezer, it doesn't usually freeze either. And like an alcoholic drink. And so an alcoholic drink is mostly water, but it has some alcohol in there. So all these chemicals lower the freezing point of water. And the cells in the plant, they're full of things, a lot of sugars, lots of like hundreds and thousands of other chemicals. And what it does is it takes some of the water out. And when you take some of the water out, but leave all the other chemicals there, the concentration goes up. So it basically makes better and better antifreeze as it's taking water out.
Yes.
So now we have these cells in the tree that don't freeze, even though it gets very cold.
Right.
So the tree is essentially making its own antifreeze, and that's how it survives the winter.
Yes.
That also kind of explains why we have some trees that grow fine in zone 5 and some, grow in zone 3 and others only grow in zone 7. the hardiness of those trees depends on how good it is at making antifreeze.
I see. Yeah,
Okay, the
yeah.
trees that are only hardy in the Carolinas, well, they're not very good at it because they don't have to be. It never gets really cold there.
Yes.
You know, in zone 5, they have to be much better, and in zone 3, they have to be even better. Right?
Yes.
It also explains the difference in cultivars. Why, for instance, we have red buds, and we have red buds that grow fine here in zone 5. But if we go down and get a red bud from the Carolinas and bring it up here, it probably will die because it's used to growing in a warmer climate.
Right, right, right.
So that's how the trees protect itself above ground. So they don't actually freeze solid.
Right, right. It's just like I'm always amazed. You take your I make freezer jam. You take your
Yeah.
strawberry jam
Yeah.
out of the freezer. If you try really hard, you can actually drive. It looks like ice, but if you try really hard, you can drive a spoon into that
Yeah.
strawberry jam, right? Because it's got all this. It's like 50% sugar, right? So um, it's not really freezing, even though it's mostly water.
Right.
That's that amazing capacity of yeah, with the that concentration. It's just a different solution, right? Um, okay, there's another thing you talk about in the woody plant chapter about apical dominance.
Right.
So
I sort of alluded to this when I talked about the buds, right?
yes,
I talked about the king bud, and woody plants have a very strong king bud. And most woody plants want to grow so that only the bud at the tip grows, right? Particularly for their main stem. So sugar maple is growing, it only wants to grow one trunk straight up. And if a lot of these side branches would grow and take over, you'd end up with a real mess of a tree.
mm-hmm.
So this top bud prevents other buds from growing, and that's apical dominance. The apical bud is the one at the top, and it creates the auxin and prevents other buds from growing. But this is a problem for trees. If something happens to that leader, the leader is the main stem,
Mm-hmm.
it suddenly loses its apical bud, and now multiple buds grow. And that's where the gardener has to come in and do a bit of pruning and correct that problem.
Right.
Otherwise, you typically end up with a messy looking tree.
You have to make a decision on which
You-
one of these branches is going to be the winner.
Yeah, you have to help it along. Now, most plants will eventually figure that out,
Yes.
but in nature, they can get pretty ugly looking before one of them becomes dominant, right? So we really
Yes.
want to help that. That's one of those things that every spring you look at all your trees and make sure you only have a single leader. If the leader's damaged, pick a new leader and force it up and prune it so it becomes the new leader.
Yes.
It's really easy to do, but it's really important for the long-term look of that plant.
Right. And potentially its efficiency as a fruit producing plant, if it's your goal.
Yeah.
There one more point about wrapping conifers, because I
Yeah.
see people doing that in every neighborhood I've ever lived. They wrap their cedars or whatever, right?
Yeah.
So you say they shouldn't. So why is that the case?
Well, we have to start with which plants did you plant? Okay. If you plant things that are not hardy in your area, then you may benefit by wrapping them. But my advice is not to do that because we have lots of choices. So you might as well pick something that actually lives in your zone, right? I mean, there are people who grow bananas in zone 5 and they wrap all kinds of things and cover them up and then go through all kinds of gyrations to survive them. So we're not talking about those things. We're talking about plants that are hardy in your area. So we have to ask the question, why are we wrapping them?
Mm-hmm.
And the reason most people wrap them is to keep them warm. And so they put burlap around them thinking that they're keeping this plant warm. That doesn't work. And I've actually gone out and tested it. You can get a thermometer, stick it inside the wrap plant and outside the wrap plant, and temperature is exactly the same. Okay, wrapping with burlap will not keep that tree warm. Now, if you wrap with plastic, it can be warmer inside on a sunny day, but that's actually harmful for these trees. So never wrap in plastic.
Okay.
But wrapping does not keep a plant warmer. So if you have a conifer that's a zone 6 conifer and you're in zone 5 and you think, well, it's It's almost hardy, so I'll just wrap it in burlap to make it survive. That's not going to work.
Mm,
But there are some good reasons for wrapping. One is deer. So deer will tend to leave the plant alone if it's got burlap around it. Right. And I used to wrap my yew out front of the house because in the winter, deer would come there and chew on it. And if I wrapped it, they wouldn't. So that's valid. The burlap will also keep wind off,
right.
and wind desiccates the plant. Remember, these are conifers, so they're green all year, and conifers are metabolizing all winter long. So even when it's cold out, they're still capturing a bit of sun, and they're still doing their leafy thing, and they're still making some food. It just at a much lower rate.
Right.
But that also means that they're losing moisture. And
Right.
a strong wind removes moisture from these conifers. And if they lose too much moisture, they can get brown tips.
Right.
So sometimes you put burlap in there just to slow down the wind. But when you do that, you shouldn't wrap the plant. You actually put a screen in front of it, a two-sided screen, just to stop the wind. You're not trying to wrap around the conifer.
I see what you mean. So you just put a windbreak. That's the idea.
Yeah.
And I guess
Uh,
with that, by doing it that way as well, by not wrapping it like a mummy, you would allow the sun to actually get at the needles, right? And it would,
that's right.
yeah,
Right. Now, the other thing that does happen with some conifers, like the upright junipers, they have these side branches that are very weak. And so if you're in an area that tends to get ice storms, the ice will build up on them and bend the branches down so far that they never come back again.
mm,
Right.
right.
But the best way to handle those is not to grow them. But if you happen to have them, then all it requires is a string. So you just wrap a string 6-8 inches apart just to hold the branches up so that the ice can't flay them down.
Right, right, right.
But
Makes
again,
sense.
wrapping them doesn't really make a lot of sense. It's the best thing to do is pick plants that are hardy, put them in your garden. If it's a conifer and you want to wrap it the first year because it doesn't have a good root system yet and can't get enough moisture, that's okay. Second year, don't wrap things.
Right,
If
right,
they
right,
don't survive, then you planted the wrong thing.
right. Yeah. All right, so we're almost done here. We're just going to talk a little bit about your environmental factors. I don't think we're getting through all the chapters here, but this is enough. If you want to read more, buy that book. It's worth reading. But you have a chapter on environmental factors and how they're important to understand if you're gardening and growing anything. We've already touched on some of this, so I'm going to skip some of the questions I had because we already sort of covered about plants and surviving the winter and the sugars and the chemistry of the plant and how it dehydrates itself to increase the concentration of the antifreeze type chemicals to survive the winter. But generally speaking, I mean, most gardeners know this, but not everyone knows this, and I always have new viewers. Why do hardiness zones matter? What's a hardiness zone and why do hardiness zones matter?
All right, so this is a little more complicated. For instance, Canada and the US have slightly different
Yes.
hardiness zones. So we assign a number to where you live, and that's the hardiness number. In general, it measures how well a plant will survive winter.
Yes.
It actually, in the US at least, it measures the lowest temperature you can get to. And it's based on that. In Canada, we base it on a number of different parameters. But it's essentially the same thing. What it says, if you're in zone 5, you can grow zone 5, 4, 3, 2, 1 plants. If you plant a zone 6 plant, it's probably going to die. Maybe not next year because we have a milder winter, and maybe not the year after, but one of these winters, it will die. Remember, hardiness zones are averages. They're long-term averages.
That's right.
It's not what happens this winter or last winter. So if you plant the wrong plants, you either have to have special protection for them or expected to die sooner or later. Right.
Right.
So it's handy when you go buying plants. Just buy plants that are really hardy in your zone.
Yes.
So it's something every gardener should know, and you should check the labels on the plants you buy, and then you know that the plant should survive.
Yeah, you cannot trust I remember buying grapes at a pretty big hardware store chain here in Nova Scotia. and they died. And when I pulled them
Yeah.
out the following, I probably waited until like July for something to happen. Nothing happened. When I pulled them out, I looked at the tag and it said Zone 7. I'm like, why the hell are you even selling these in Nova Scotia? Just ridiculous. Everyone who bought those, they died.
Yeah.
Guaranteed,
Now,
right?
yeah. Now there is one other thing that people have to understand is the winter hardiness is not the only thing that kills plants,
Right.
right? So soil type is important, and how wet your soil is important, and so on. So there are other criteria that make a plant survive. Hardiness is only looking at low temperatures. Right?
Yes.
So you buy a plant that needs to be really wet and you put it in a sandy garden and never water it, it's not gonna live there, and it has nothing to do with temperature or the zone.
Right.
Yeah.
Yeah, it's like I think it was you I had on my show. I had half of one of my beds of garlic die. Now it's a variety of garlic that's hardy to zone 3. Half of them died. And so your theory, and I think it was correct, was just that soil was too wet and too exposed, because it's very rare we have a winter where it starts snowing in December and the snow accumulates and continues to accumulate until some point in March when things warm. It doesn't work that way here.
No.
We had some snow and then it rains. Actually, it's usually after a really good rain, after all the snow has disappeared, that it'll be minus double-digit cold.
Yeah.
So you've got your garlic that's 2 inches below the soil, and it's minus 20, and it's encased in ice, right?
Yeah.
And it's so I mean the garlic that died, they were at grade, and all the other garlic were in a slightly raised bed,
Yeah.
right? So I don't think they were encased in ice to the same extent.
Yeah.
So the ones that were just, but anyway, I'm interrupting here. So hardness zones matter for perennials and things that, or even
Well,
things that overwinter, like garlic.
Yeah. Anything you have out over winter, hardness zone is important. Yeah.
Right. Yes. And they're different depending. I often get viewers that'll say, I'm in zone 6. I'm in Washington. I have the same growing conditions as you. And I'm like, I don't think you do. So that's interesting that, I don't know why we have these different measurements for these sorts of things, but so that matters. But how about run through, if you have in your mind, a list of all the things that can kill a plant during the winter. We just talked about a couple, and if there's more, and if there isn't, we'll just move on to the next question. But I mean, aside from it just being a winter where it actually hits, let's say I'm in zone 5 and I plant a zone 5 variety of plant, and the plants die. What are the reasons they died? Because obviously it's a zone 5 plant, and let's say I had a normal zone 5 year, and the plant died.
Well, the first thing to remember is it's not necessarily dying because of the winter, right? It may be what happened last summer, and it doesn't come up in spring. So we can't necessarily blame the winter. A lot of rock garden plants, for instance, are designed to grow in very cold climates, but they can be very hard to grow in zone 5 because our winters are too wet. Right. So up in the mountains, they don't get a lot of precipitation in the winter, or if they do, it's snow. And so they're not sitting in wet, and it's very sandy soil. Now bring them into my garden, it's clay. We have these warm periods and cold periods and so on. Our soil gets really wet. They don't like that. They can't take a lot of moisture around the crown of the plant. So moisture is a problem. I've also tried growing these blue poppies, which are just gorgeous, and they just won't grow here, whereas they will grow in Quebec City, which is the same climate. It's not far from here, but here they don't grow, and I suspect it's because our summer humidity is too high. They're
humidity.
Cool growers. Okay, they like to be cool, and our summers are too hot and too humid, and that. So they don't grow well all summer, and by fall they're ready to give up the ghost, and they die over the winter. It appears like they die over the winter, but They're sort of dead before winter even gets here.
Right, right.
So humidity can be a problem. Day temperatures in the summertime can be a problem for a lot of plants. They just want to grow cooler. My property is called Aspen Grove Gardens because I have a lot of aspens on the property. And I'm just at the bottom edge of the aspen range. Okay, it's too warm here for aspens, so they don't grow very long. Once the trunk is, you know, 15 inches across, the trees die.
Oh,
And we expect that as global warming happens, all the aspens here will disappear because they like growing in zone 3. It's too hot here. This is like their southern zone, right?
right.
So here's a plant that is going to look like it dies off every winter because it's too hot in the summertime.
I see.
Some plants can't take clay soil, which is another big problem.
Right.
The other one that I think we don't talk nearly enough about is that a lot of so-called perennial plants really aren't perennial. They're short-lived perennials, right? So there's the penstemon, for instance, which are North American natives. Many of the penstemons will grow up, flower, and then don't come back the next year.
Right.
We call them perennials, but even in nature, they're not long-lived. They self-seed themselves all the time.
I
Right?
see.
But they do come back for a couple years, and then they die out. Right? Lupins is another one. You probably have lupins everywhere out there.
Yeah,
right?
we do.
Well, in Ontario, lupins are short-lived plants. Okay, they're perennial, but after they bloom, they might come back the second year and bloom, and then they're gone. Right? And I think our summers are too warm for lupins.
Oh, right.
So again, that's not a winter coldness issue.
Right.
It's a summer warmness issue. But here, lupins are not perennial, except for a couple of years. And out where you are, there's sort of weeds, right? They grow everywhere in the fields and so on.
Yeah.
And out west too. If you go out west in Alberta and so on, or north in Ontario, they grow all over the place. They're just a common weed. And here, I can't grow them for very long. I have to keep starting them from seed every year.
When my wife and I got married, we actually had some of our pictures done. We had a friend that had a huge pile of lupins in their backyard, just natural, just wild on the ocean. And we got pictures taken with the lupins.
Yeah.
Just all over the place on the side of the road here. I've never been able to get them to, I've gathered them and thrown them all over my property. I can't get them to grow. But they do that. Oh, Jesus, thing's going off again. Hang on a sec here.
Man subject to the previous alert has been taken into custody.
All right, they got him. Hooray. All right. They got the guy with the knife. Thank God. Oh, God. Every time that goes off, I think there's some guy out in my street, because you don't know. It's somewhere like in the area, but that guy's a pretty substantial drive away. Okay, so one more question about this. Two-part question. So you got your hardiness zone, and I don't think we all fully grasp the importance of snow in a northern garden and how it can really affect the survival rate of some plants. So talk about snow and talk about mulch. Okay.
Right. So earlier in the program, we talked about the heat coming up through the soil layer.
Yes.
And it gets to the top of the soil, and very quickly it just disappears into the air.
Yeah.
Right? Whenever we put something on top of the soil, we actually trap the heat in. It's like putting a blanket on the soil.
Yes.
So both snow and mulch do that. That's a 2 or 3 inch blanket we put on there. Now the soil stays much warmer with that blanket on it. And it turns out that snow is one of the best insulators. In fact, if you've ever gone winter camping, one of the best ways to survive is get something that's waterproof and then cover yourself with snow, and you'll be toasty warm. I mean, the igloo's kind of like that too. It's a covering of snow. So snow has a lot of air in it. It's light and fluffy. It's a great insulator. So when we have a foot of snow on the ground, the roots of plants almost never freeze. It's become really warm. It has to get really, really cold for them to freeze. So that lets them overwinter much easier. And what you really want is once it gets cool in December, we want a foot of snow, and then it stays there all winter long till spring. And that would be great. And in fact, if you go north of where I am, where they do get more snow, they can grow things there that I can't, because their plants are completely covered in snow all winter. Those plants really don't get a winter. They don't get cold temperatures.
Even though it's colder.
Even though it's colder. The air is colder, but that's above the snow. Below the snow, it's actually warmer than it is here.
Yes.
And we have the same problem you have. The snow melts, and now our ground is bare, and then we'll have a minus 20 degrees centigrade night, and it gets very cold, right? But with that layer, we don't have that problem. So mulch does the same thing. So wood chips or straw or anything you use on the ground will also keep the area around the roots warmer. But there's a downside to this, and that comes in the spring, because it also keeps the soil cooler in the spring, right? And you can see that if you mulch and go out, whenever you can early, like right now would be perfect, and move some mulch away in an area, like a square foot area, and then come out in a couple months, another month from now, when a sunny day is coming down, the soil is all nice and warm, and the ice is out of it where it's bare, and then start digging where the mulch is, and you'll find the soil still frozen.
Yes.
That's not necessarily bad for plants, because what the plant roots don't want is these rapid changes, warm, cold. That's what really harms plants. So if you keep that soil frozen longer in spring, that's fine for most perennial herbaceous type plants, trees and shrubs like it. Where it may not be a good idea is in a vegetable garden, where we want an early spring. Right? And so, for instance, the garlic bed, I keep it covered now with straw, but as soon as I can, I take the straw off, because I want the sun to come down and heat the soil and get that garlic growing, so it grows as big as possible before harvest. I also do that where I'm going to plant my peas. So I'll come in as early as I can. I'll rake that straw away from where I'm going to plant my peas, because I want the soil to warm up so the peas will grow.
Right.
So for vegetable gardening, you might want to remove some of that mulch, even in the fall, so that soil can experience the warm temperatures.
Right.
But in most of the garden, all the permanent plantings, you can just leave the mulch, because it just means that winter lasts a bit longer, but that's better for the plants.
Yeah. No, it's a real dilemma, and I leave it on my garlic, just more out of laziness, because it's such a good weed suppressor. But last year I experimented with I had a problem with my asparagus, where I find if I leave, at least where I am, my situation, if I leave the mulch on the asparagus, when the shoots are forming and they're like below, they haven't punched through the mulch yet, but they've emerged, they get hammered by slugs and snails really bad, such that they don't even realize, like they don't even make it, right?
They never make it,
cut right off, right? And so I did an experiment yesterday, last year, I took all the mulch off, and they grew. Also, they grew faster. Right. They grew while it was still very cold at night. So they sort of, and because once they reach a certain size, they're woody enough. You take a few off, but then they're woody enough that they can survive. When they're really young and they're like 3 inches high, they just get cut right off by some of these slugs and snails. Now the flip side was that every damn weed seed in the world that was in the seed bank in the soil had every kind of weed you could imagine, whereas normally I don't have a lot of weeds. So I had to go back at some point, once the plants were like yay high, deal with every weed, put some sort of something down and remulch it, and it was so much more work. I'd love to have a more slug proof variety of asparagus. But yeah, I agree. That's the flip side of it. It's, and for me, I found because we don't have persistent snow,
Yeah.
I basically use mulch as a snow.
Yeah.
This is the only way to sort of,
Only way.
to keep the soil, it doesn't keep the soil from freezing, but it doesn't. Part of the paradox is that the soil doesn't freeze as much. So you've got one soil that's not covered and another soil that is. The one that's not covered freezes as frozen and as deeply frozen as it can possibly be, but begins to thaw sooner.
Yeah.
The other one, it might take longer to thaw, but it might not be as deeply frozen. So the freeze might only go 3 inches deep, whereas the one that's bare, it might go 6, 7, 8 inches deep. Sort of, the frost might go quite far. So, and it really depends on what you're trying to plant. Like I've found years experimenting with spinach that you can have the top 2 inches thawed, almost like in the north where you got like a permafrost, right?
Yeah.
And so you got like frost down 5 inches deep, and the spinach is growing above ice.
Yeah.
And it's just doing fine. I find that fascinating that it can happen. Anyway, I think we've covered the book pretty good. People a good sense, but there's a lot more in this book. We've only covered a few, just the things that piqued my interest when I was reading. It's a very dense book with a lot of piece of information in it, and depending on what you're growing and what you're into, I think it's definitely worth the read. And it's one of those books where I probably have to read it twice to get some of this information locked in. But yeah, Robert, thanks for coming on talking about this. I can't wait to get you back to talk about your next book. And I can't wait to get a copy of it. So send that along. And we'll definitely have you on to discuss that.
Yeah. Well, thanks very much for having me. It was great.
Right on.
Yeah, it's always fun.
Yes. All right, everyone. Well, thanks for watching. Thanks for listening. And until next time, get out there, get at it, have fun in your garden. Thanks for watching. Thanks a lot, Robert. Hey, if you want to help support everything I'm doing here, go to Deficiencies.com to buy whatever you need for your garden this year. And use my coupon code GAVS23 to get free shipping as long as there's a pack of seeds in the order and there's no oversized items in the order. Check out the description box of this video for details. You can buy everything you need from Deficiencies. They have seeds, fruit bushes and trees, soil amendments, pest solutions, tools, clothing, and lots of other stuff too. So yeah, if you want to help support everything I'm doing here and they sell something you need, buy it from them using my coupon code, and happy gardening.